Wade.
Hey, Carly.
So today we're going to talk about polling and sampling.
Awesome.
And we're going to kind of move beyond the idea of looking at gambling games or random variables where we're looking at things like dice, coins, cards, and actually talk about collecting data. So with polling and sampling, you might be wondering, why would people want to take a poll? Public opinion polls are posted all the time. And the idea is we want to know something about a population. So let's just say we have a big giant population. A lot of times for polls, the population is US adults. We might want to know, what do all US adults think about something? And the best way to get the answer to this question would be to actually ask every single US adult your question, and then you would have a very accurate answer. But the problem is that's incredibly difficult to do. It's time consuming, it costs money, and honestly, it's almost impossible. So instead, we use something called inference. And what inference is basically using what we know about a sample from this population to estimate what we would get in a sample. So most polls, basically what happens is we have our population, say it's US adults, we will randomly sample a certain amount, let's just say it can be any amount, 100 people, and then we will get what we call these sample statistics, and we can use them as estimates of our population parameters. So I like to think of poll designing as having three key parts. So the first part in designing a good poll is that we want to make sure that we use random sampling. Just like when we talked about experimental design, we said the best way to divide subjects into a treatment and control group is to do it randomly. Same idea for sampling. If we want a representative sample of all US adults, we want to make sure that we randomly sample out of the population. And if we don't randomly sample, then we could get a biased sample. So our second thing we want to do to design a good poll is to reduce bias. So there are a bunch of different types of bias. We can have sampling bias, where maybe instead of randomly sampling people, maybe because it's convenient, I just ask the Stat 107 students, and that wouldn't be a random sample of all US adults. It's important to know that whatever your population is, your sample is only representative of that population it was drawn from. And then the last thing to keep in mind when designing a good poll is that we want to actually reduce what I like to call chance error, or error in general. And in this series, we're going to talk about how to measure error through something called the standard error. And the best way to reduce chance error, if we're looking at averages or percents, which a lot of times in polls we might want to know what percent of US adults think something, like an example that Wade and I like to ask in our surveys is, what percent of people have iPhones versus another type of phone versus Androids? So Wade, you have an Android, right?
I have an Android, and I'm 100% team Android.
He is team Android. I have an iPhone, so I'm team iPhone. And usually what we see is in our classes, when our population is our Stat 107 class, we see that more students have iPhones.
It's like 80% of students in Stat 107 would have an iPhone.
Exactly. So we can reduce chance error by actually sampling more and more people, because our goal when sampling is to basically have our sample be as close to the population as possible. So obviously, the more people we sample, the closer our sample is going to be to that population. So using these key ideas, we can evaluate polls or samples that have already been taken, and kind of also use this if we want to do our own polling and sampling in this class. So we're going to nerd out with this a lot more, but that's just kind of an intro to polling and sampling.